It is a well-known fact that compressed air is the most expensive utility on the shop floor. However, non-availability of compressed air just at the right time is even more expensive. Learn how a car company used machine learning and artificial intelligence solutions to predict compressor failures and save millions. Today's story is based in mid 2000s back in the US. During such times, at a car company, its compressor was failing more than once a year without any notice. The company was losing millions because of non-availability of compressed air, because a car was getting rolled off its plant every 25 seconds. The plant in charge of this car company was a worried man, since non-availability of compressed air meant the painting or finishing operations were affected, the pneumatic tools remained ineffective, even the breathing air filters remained offline, endangering the health of workers on the shop floor. Now let's understand what exactly was the problem. This car manufacturing company had a multi-million dollar compressed air system consisting of 12 centrifugal air compressors, almost of the size of a small truck. The blades of these compressors rotated at almost 20,000 RPM, almost a fraction of an inch from its housing. Now, if you can imagine what will happen if the blade touches the housing. However, the blade's wobble was not the cause of the crash. It was the result. The crash or surge was result of a reverse flow, which happened because the normal direction of the airflow from the compressor to a pipe was reversed and the air inside the pipe pushed back. And this is where our hero mechanical engineer steps in. This engineer, back in mid 2000s, thinks about a futuristic world where all the machines are connected with each other to a central unit and provide data for intelligent maintenance. He thinks that all the machines are like patients and the data coming out of its sensors is like blood. Hidden inside the data is meaning about the deviant behavior of a machine or process. Unlocking this meaning leads to predicting quality, determining the stability of a machine or a process, and predicting future failures. And this exactly is what Industry 4.0 is today. Trivia time. Do you know where and when the term Industry 4.0 was coined? Mention your answers in the comment section below. Our mechanical engineering hero, along with a team of his data analysts, joined the plant in charge and some skilled maintenance workers and got to solve this problem at the car manufacturing company. And they started with asking simple questions to solve this complex issue. Questions like, can we predict a reverse flow before it causes a crash? Can we see something developing in the data over time to predict this failure? The team decided to install sensors on various locations on the compressor, and they collected data and analyzed the data for months together from a compressor and tried to look for anomalies. Sometimes the team would create surge-like conditions or approach to surge-like conditions on purpose and see how it reflected in the data set. Finally, the team's hard work paid off and they found the root cause that was causing this failure. From the data, the team understood that the best predictor of our incipient surge-like conditions happened at stage 2. That is, in a 4-stage compressor, the deviant behavior started at stage 2, which led to eventual failure of the complete system. Now, the very fact that they found this deviant behavior starting earlier, it provided ample time and warning to take corrective action. With this data and the proof from the design of experiment led to the company investing in good quality sensors for all the compressors and they started getting data from all the compressors. Now, this data was fed into a central intelligent unit, and an algorithm was developed to predict the failure earlier. Further tests confirmed that this phenomenon was observed across all the compressors. That is, the wobble or the surge like conditions happened at stage 2 of every compressor, which led to failure of that particular compressor. So that means corrective action could be taken on time, and probably the compressor or the deviant compressor could be bypassed. What was the result of all this data gathering and analysis and developing of machine learning algorithms? The result was that after implementation of this solution, there was absolutely no unplanned crashing or shutdown of the compressed air system. Now, this meant better predictability and control of the system, which played a huge part in improving the bottom line for the company. Now, why did I choose to tell this story? I am not a machine learning or a artificial intelligence expert. I am a mechanical engineer. But this story, which is based in 2000s, it just shows that as mechanical engineers, we should not create boundaries in thinking. We should not be crippled by the fact that we are not a machine learning expert or we are not artificial intelligence expert. Nobody is. These are new technologies that are coming up. And we as mechanical engineers need to find where we can implement or use these tools to solve our problems. It is an unfound mistake in thinking that these new tools like machine learning are going to disrupt the job market. No, this is a challenge or a new opportunity for budding new mechanical engineers to come up with innovative solutions to current problems. I sincerely thank you for watching this episode of our Think Filter show. I am really obsessed with knowing or getting to know these mechanical engineering success stories because I get inspired after reading or watching such stories. I hope this story inspired you in any meaningful way. If you are, please stay tuned for further episodes next week. Thank you.